All right, you guys. So you should have pulled up the practice worksheet that we started yesterday. And then this is on the end or the bottom of the second page. So isosceles and equilateral practice. So we've been doing some algebra problems with incongruent triangles. And so since we learned about isosceles and equilateral triangles last week, I thought it would be nice to do some algebra problems with those two types of triangles. So just a reminder, isosceles triangles have two sides that are congruent and two angles that are congruent. And then for an equilateral triangle, there are three sides that are congruent and three angles that are congruent. And remember last week we talked about if all of the three angles have to add up to 180 degrees, and in an equilateral triangle all three are equal, then each angle would have to be 60 degrees. So that'll be important moving forward in some of these problems. All right, so 1 through 4, these problems are all going to deal with either isosceles or equilateral triangles. There's a couple of different types of questions that I could ask you. So number 1 says classified triangle ABC. I want to know what type of triangle is it. Is it an isosceles triangle? Is it an equilateral triangle? Or it could be neither. So what I'm given is I have angles. I have angle B, angle A, and angle C. I have measurements on there. And so I'm going to use relationships I know that are true in all triangles. And in all triangles, hopefully this should be ingrained in your mind now, all three angles add up to 180 degrees. So what I'm going to do is I'm going to add these three measurements together. And then once I get an answer for X, I'm going to plug X into each angle and then see what I get and see if that tells me if it's an isosceles or equilateral triangle or not. So I'm going to add these together. So 8X minus 12 plus 3x plus 40 plus 5x plus 24, running out of room, equals 180. All right, so combining my like terms, I have 8x, 3x, and 5x. That's 16x. Then I also have negative 12 plus 40, that's 28, plus 24 is 52. So I have 16x plus 52 equals 180. I'll subtract 52. 16x equals 128. Divide both sides by 16. And we get 8. So x is equal to 8. All right, well, just knowing x doesn't necessarily tell me what type of triangle this is. So I'm going to go through and I'm going to plug in or substitute x, 8 in for x everywhere that I see an x. So up here, 8 times 8 minus 12. So that's 64 minus 12. That's 52 degrees. All right, down here, 3 times 8 plus 40. That's 24 plus 40, which is 64 degrees. And then over here, 5 times 8 plus 24. 40 plus 24 is 64. All right, I'm just going to move the 64s in the triangle. So now I have all three angles labeled. I have a 52-degree angle, and I have two 64-degree angles. So hopefully what you're thinking is I have two angles that are congruent, and if two angles are congruent, then this is an isosceles triangle. So now I know that triangle ABC is isosceles. Now let's say I plugged in 8 for everywhere I see an X, and I ended up finding that all of the angles were 60 degrees, then it would have been equilateral. So that's the difference. Here we had two equal angles, 64 and 64, so that's why this is isosceles. All right. Number 2. So number 2, we're given this triangle PAL. We want to figure out the value of X and then the measure of each of those angles. All right, well, looking at this triangle, it looks like I have two tick marks here, which means two sides are congruent. If two sides are congruent, then I have an isosceles triangle. So right away, I know that this is an isosceles triangle. In an isosceles triangle, two sides are the same and two angles are the same. That's going to be important because I have measurements on two of my angles. Well, remember last week we said the side that isn't equal to the others, so in that case, or in this case, that would be PL, that's called the base. And the angles that are at the base are equal. So I have, oh, there's the bell. I have measurements on both of those angles, And since they're equal, I can equal the measurements to each other. So 5x minus 10 equals 3x plus 10. So I'm going to solve for x here. I'm going to add 10 to both sides. Get all my x's on one side. Divide by 2. All right, x is equal to 10. Okay, so now that I know that x is equal to 10, I can substitute it in anytime I see an x. So I'm going to do that here. So 5 times 10 minus 10. So 15 minus 10. All right, angle at P, so APL is 40 degrees. ALP, well, it should be 40. I'll just check. 3 times 10 plus 10. Yep, that's 40 degrees. All right, PAL up here, putting a question mark there. So I have my triangle. I know 2 of the 3 angles. And again, hopefully this is just stuck in your mind from the last 2 days. All 3 angles in a triangle have to add up to 180 degrees. So if I know 2 of them are 40, I'm going to take 180, subtract both of those 40s, and that's going to leave me with 100. So this angle PAL is 100 degrees. Now, if we didn't know the properties of an isosceles triangle, knowing that those 2 angles were equal, we wouldn't have been able to solve for x. So knowing those properties of both isosceles and equilateral triangles are really important. All right, moving on to number 3. So this time it says that triangle VAN is equilateral. So I know that I have 3 sides that are the same. I have 3 angles that are the same. All right, we've got W and X to find and the perimeter of the triangle. So let's start with W. So W is part of angle V right here. And I know that all 3 angles are equal. And, I want to use the fact that in an equilateral triangle, all the angles have to equal 60 degrees. That's going to be really important because down here, I don't really have anything else labeled on my angles. So if I know that all of these are going to be 60, I'm going to label that here. And then I have an expression 4W minus 8. I can equal it to 60. So I can say that 4W minus 8 equals 60, and that'll let me solve for W. So I'm going to add 8 to both sides. And I get 17. So W equals 17. Again, it doesn't mean that that angle is 17 degrees. It's just W. So if I were to substitute 17 in for W, I would get 60 degrees. All right, so we're done with the angle part. Let's move on to the segment part. So I have 2 segments that have X in them. So I want to know, are those segments equal? Well, this is an equilateral triangle, so the segments are equal. So I'm just going to equal them to each other. So 4x minus 3 equals 2x plus 9. And then I'll solve for x. So 2x equals 12. Dividing by 2 gives me x equals 6. All right. Now for the perimeter. We haven't really talked about perimeter much this year. Perimeter is when you're adding up all the side lengths of a shape. So this is a triangle. There are 3 sides. I have to add up each side and figure out the perimeter. So right now I don't actually know the length of each side. Right now I just know that I've just gotten x. And then on my sides I have a couple expressions with x. So since we know what x is, I'm going to plug or substitute 6 in for x. So here, 4 times 6 minus 3. So that's 24 minus 3, which is 21. I can do it over here. I'm just going to check that I do get 21. I should, though, because it's an equilateral triangle, so all the sides are going to be the same. So 2 times 6 is 12, plus 9. Yep, that's 21. And the third side has to be 21. This is equilateral. Now for the perimeter, just put P for perimeter. I'm adding up all 3 sides. 21 plus 21 plus 21. That gives me 63. And another bell. All right, so 63, I don't have a measurement like centimeters or inches, so I'm just going to say units. 63 units. All right, so again, for equilateral, that was important to know those properties, that all three sides are equal, all three angles are equal, and each angle for an equilateral triangle is equal to 60 degrees. All right, one more. So number 4, we're given a triangle. We don't have the picture. If you want to draw the picture, you can. So I will. You don't have to. Triangle GEO. And angle G is 6B plus 18. Angle E is 8B plus 4. Angle O is 10B minus 10. All right, it says classify triangle GEO. So that means figure out what type of triangle it is, just like we did up here in number 1. So if I look back at what I'm given, again, I'm given 3 angle measures. Well, I know that for any type of triangle, regardless if it's equilateral or isosceles, the angles always have to add up to 180 degrees. So that's how I'm going to solve for B. So I'm going to add the 3 angles together. Equal to 180. Once I solve for B, I'll plug it in to each angle, substitute it in, and then see if I have any equal angles. All right, so I have 8B, 6B, and 10B. So that's 24B. And I have 4 and 18, which is 22. 22 minus 10 is 12. So 24B plus 12 equals 180. Subtracting 12 is 168. And if I divide by 24, I get B equals 7. All right, now that I know what B is, I'm going to take that number, 7, substitute it in for each of these angles. So here I have 6 times 7 plus 18. 6 times 7 is 42. 42 plus 18 is 60 degrees. Over here, 10 times 7 minus 10. That's 70 minus 10, which is also 60 degrees. Okay. And then when I plug it in up here, 8 times 7 plus 4, that's 56 plus 4, 60 degrees. All right. I have 3 equal angles here. They're all 60 degrees. So hopefully you know, based on the properties of an equilateral triangle, 3 equal angles, all 60 degrees. This is an equilateral triangle. In fact, once I had that 2 of them were 60 degrees, I knew the third one had to be. So I didn't even have to plug it into the third one, but it's always good to check. So this is an equilateral triangle. All right. So hopefully those were kind of a review of the properties of the triangles, but the applying it with algebra was probably new. And so what you guys are going to do is you're going to go ahead and do just 2 homework problems, and I'm going to have you turn that in. All right, so you're going to find that assignment also posted on Classroom. One's going to be similar to an equilateral or an isosceles triangle problem, and then one's going to be what we did the last 2 days with our CPCTC, matching up sides and angles of congruent triangles. So if you have any questions on those 2, please let me know, and I'd be happy to meet with you and go over them.